So in this video, we're going to apply the principles that we've been talking about for the last few videos to write the electron configuration for silver. Silver has the symbol Ag. It's one of these ones that doesn't, the first letter of the name of the element does not match the first letter of the symbol because it was known by a Latin name previously. And it's atomic number 47. So let's switch over to the periodic table and find it. So it's right here, element number 47. So we're going to use the condensed notation where we use the noble gas configuration. So we can look at the row prior, go all the way to the right, and our shorthand is that we can say krypton. Krypton is our core electrons. So we'll start there. That'll be our simplest thing that we can start with, is we can say the core electrons are the same as that of krypton. So again, this is representing our core electrons, and what that means is, coming back to the periodic table, we can sort of map this out. It means our 1s orbital is filled, our 2s orbital is filled, our 2p orbital is filled, our 3s orbital is filled, our 3p orbital is filled, our 4s orbital is filled, our 3d orbital is filled, our 4p orbital is filled. That's saying a lot, but right, that's what when we write krypton, it's a shorthand for all of that. All those lower energy orbitals are already filled, and now we're just going to worry about the valence electrons. So how many valence electrons do we need to worry about? Well, we filled in 36 electrons because krypton has an atomic number of 36. So that means we're going to fill in electrons into a 5s orbital. We can see that because these elements here, right, are part of this, what we call the s block. These are where s orbitals are the valence electrons, the last ones being filled. So we're going to have 2 electrons in a 5s orbital. So again, switching back, and we need to go back and forth between our, so we're going to have 5s, we'll have 2 electrons there. And then let's count up how many. Next, we'll fill up the 4d orbitals, and we can tell because this has it has 10 electrons going to get filled across this set of elements here. So we need to fill in 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll have 9 electrons in 4d orbitals. So that's the electron configuration of silver. Now we more properly should write this with the 4d9 first. We put the lower value of n first, even though we fill in the s orbitals first. I would accept either one of these as being correct on an exam. So don't worry, this is not a big deal. But that is a simple way of looking at how we fill in the electron configurations. So coming back to our periodic table, let me find the figure I'm trying to find. Just want to show a figure from your textbook that I think summarizes what I was trying to say in the previous video as well, and just now, is that we have this figure here, except for I need to make it bigger so you can actually read it. Well, we have different sort of sections of the periodic table that correspond to these different orbitals being filled. So on the on the left-hand side of the periodic table, this is what's called the s block, because here the final electrons being filled in are the s electrons, and that's how these elements all behave similarly along the same column of the periodic table. In our first column of the periodic table, everything has 1 electron in an s orbital, and so they all behave similarly. Column 2, they have 2 electrons in s orbitals, and those are the valence electrons. In the middle section here, we have the d block, because this is where the d orbitals are getting filled in. Over here, we have the p block. And one spot that I haven't talked about yet, but that we'll get practice with as well, is the f orbitals start to get filled in as we get to the bottom of the periodic table. So down here we have the f block. And this is once we get to row 6 of the periodic table. We fill in the f orbitals, and then the d orbitals, and then the p orbitals. And it's for the previous number. So we can see the 4f orbitals get filled in this row, and the 5f orbitals get filled in this row. But the shape of the periodic table reflects all of these things we've been talking about with orbitals in the atoms. And explains why we see these properties of elements in the same column of the periodic table, and why we also see trends, and we're going to be talking about these trends across the periodic table as we continue through this chapter. There are trends in different properties of the atoms that are due to the fact that we have different sorts of orbitals being filled, as well as the sizes of those orbitals and how that affects how elements behave. So that concludes our section, our little mini section here about filling in electrons and electron configurations. We're going to get lots of practice with this on homework questions as well as in class. So I hope you enjoyed these videos.